Hello class, today I'm gonna go over section 2.1, which is basic definition of function, finding domain of function, evaluating function. And this is homework 11 on your homework and your assignments. So first I'm gonna go over a few definitions, and this handout is gonna be available also for you, so you can review it later. So basic definitions, we have relation. What is relation? It's a set of ordered pairs. So we have three examples here. So ordered pair, you know, it's like coordinate of point. The first number is represent X. The second number always represent the Y. And so if you have pairs like this, those represent relations. Now, a domain, it's the definition of domain is a set of all first component of the relation. So looking at my example 1, so this is the 95 is the domain from the domain, the first coordinate, 83 is the first coordinate, 34, 67, all the first numbers on this pair is the domain. If I look at example 2, I have 1, 3, 9, 15. Only the first number are part of the domain. The same way, for example, 3, we're going to have 2, 4, 2, and 5 is from the domain. Okay, so you have here, you can write all of this down. I'm not going to write this right now. And what is the range? So domain is the first coordinate, which represent X. Domain, remember, always represent X. And the range is the second component of the relation, which always represent Y. So domain is X, the range is Y. That's how it's easier to remember. So what are the elements of the range? So looking at the, we should be range here. So what are the elements of the range? So looking at my example 1, the range, I'm just going to use different color. The range is going to be A and B and F and D and C and A. So those are the elements from the range, which is the Y coordinate of the point of those ordered pair. The same way, for example, 2, probably you already noticed that the elements of the range are going to be 7, 11, 23, 35. And the same way for the example 3, we're going to have 8, 7, 4, and 9 other elements of the range. So always remember, if you have ordered pair, we talk about coordinates of point. So every time you have ordered pair, the first number is X, the second number is always Y. You already know that from coordinates of points. But here we're talking about relations which pretty much have the same notation. X is the first number or the first element, Y is the second. X represents domain of that relation, Y represents the range of that relation. Okay? So that's what relation is, that's what is domain and range. Now, the function, it's a relation, which means you have function always have X and Y, where the elements of the domain correspond to only one element of the range. So that means, to put it simply, that means the first coordinates always have to be different, always have to be unique. That's what is important here. All the X's have to be different in order to have a function. So let's look at example 1. Example 1, is it a function or not a function? How you know? You're going to look at the X's. We're going to look at the yellow highlighted numbers. Are they different? Do we have repeating numbers here? Looking at all the yellow highlighted numbers, 95, 83, 34, 67, 78, and 89.5, they're all different. So that means the function, the example 1 is a function. So example 1, I'm just going to write it here. Yes, it's a function. Okay, let's look at example 2. Example 2, we have the elements of the domain 1, 3, 9, and 15 in example 2. All these numbers are different. So that means the example 2 is also a function because why? It says why? Because X's are different. Now let's look at my example 3. So we have the numbers 2, 4, 2, 5. So looking at those x coordinates, we have two repeating ones. We have 1, 2 here, and we have 1, 2 here. So what that means, for two repeating x's, this relation is not a function. Why is not a function? Because we have repeating x. Okay? So that's how you know if it's a function or not. You take the relation, you take the points. If all the x's are different, yes, it's a function. So here we have another example. It's like graphical example of we have domain. So this is kind of visual what that means. So all the first elements, all the blue elements A, B, C, D here, they are elements of the domain, and the range, the red one, 1, 2, 3, 4. So the relation here is represented with this little arrow. So one from the first, this is the first example here. This is where we're going to look in right now. Okay, only here. So we're going to check if this is a function or not a function. So looking at the one I boxed it in the red. So from A, I'm going to go to 1. From B, I'm going to go to 3. From C, I'm going to go to 3. D is going to go to 4. So the elements of the domain are A, B, C, D. The elements of the range are 1, 3, and 4. So is that a function or not? Yes, it's a function because if I want to list this like an ordered pair, I'm going to try to write it here. So if I want to list the ordered pair here, is going to be, I'm going to list the ordered pair for this example. So the pair is going to be A and 1, okay? That's the first one. A is the X, 1 is the Y. Okay, the second element, the second ordered pair is going to be B and 3. The next one is going to be C and 3. And the last one is, the last ordered pair is going to be G and 4. So if you list it like this, like a coordinates, like a pairs, we see that all the elements from the domain, which are A, B, C, and D, they're gonna be, sorry, something happened here. So all the elements here I'm trying to get this. Okay, there you go. Okay, so all the all the elements we have, looking here, all the x's are different. We have A, B, C, D, they're different. So if you have a diagram like this, you can just see if from elements of the domains, you see down here, you have X, you have Y. So those are elements of the domain. This is X, this is Y here. So if it's coming one error, then this is a function. So the answer here, it's a function. Now looking at the second example, and I'm going to make this green box. It says it's not a function, but let's see why it's not a function. Because we have A goes to 1, B goes to 1, which is okay. The Y can be repeating. Now looking at C, what's happened here with C? C go to 2 and C go to 3. So that's why this is not a function, because we have point C and 3, and the other one, the other coordinate is going to be C and 2. So you have from C, from XC, you're going to get Y2, and from the same X, you're going to get Y3. This is not possible because the function, the definition of function is a relation which they correspond one and only one element from the domain. So that means all the x's, all the first coordinates are unique. Okay, so that's what function means. How you evaluate function? You have different ways to represent function. One way is if you have it a pair like a coordinates. Another way is a little diagram we just saw. We have also equation of function, and we have graph of function. So the example here we have given is in this graph. We have the graph on my right side on the screen, and we have, this is the graph of the function, and what you need to find, we have, this is the functional notation, g of x. G of x means we have a function, and g of x represents the y coordinate. So here they asked me to find what is g of -2. So this -2 is going to be x. So I'm going to go in my graph on the x-axis. X is -2. This is the point there, -2. And they're asking what is the y coordinate for that point. So looking at this point, the coordinates of that point are -2 and 0. So that means, so the point, I'm going to put the point also here, it's -2, 0. So they're asking what is the y. See, they're asking y equals. So what is y? Y is going to be equals to 0. Okay, so that's your answer, y equals 0. That's what they're asking, what is y? Okay, the next example is absolutely the same way, but here they're asking me what is y equals g of 2. So in this case, x is 2. So they give me the 2. So always the number inside, if you compare here, the number inside is x. Inside the parentheses is x. So now, what is that y? So we're going to go x is 2. This is x is 2. And then I'm going to go to the graph. So you can just go up or down, doesn't matter. You have to go to the point on the graph. So I'm going to go this point here. So this is the point. And the coordinates for these points are 2 and -8. So I'm going to write the point also here. So the point is when x is 2, the point on the graph is going to be -8. So looking at these coordinates of the point, we know that y coordinate is going to be equals to -8. So that's how you find the coordinates from the graph. Now let's look at the next example. And the next example, it says 4 equals g of x. So here we need to find what is x. That's what you're looking for here. What is x? They give me what? They give me the y. What is the y? The y is 4. So we're going to go y is 4, which is right here in the y-axis. And then you're going to just kind of do a horizontal line to see when y is 4, where you cross the graph. So you have 2 points here. One point is in this point here, and the other one you're crossing over here. So we have 2 x's when y is 4. So let's see what are the x's. The first one is going to be when I go to the x-axis. Over here is going to be -1. So we're going to have x is -1. That's one of the points here. And then when I go down, it's going to be about, I'm just going to say 3 point something. It's right after 3, right? Over here somewhere. It's like 3, let's say 3.5. Okay. In examples like this, we can approximate. It says to the nearest integer. That's what it says. So let's see, looking at this graph. So it's about between 3 and, it's closer to 3 actually. If I look closer to the graph here. Yeah, let's look. I'm just going to zoom it to see if it's close to 3, yes. So this point here, when you go down, it's close to 3. So I'm just going to take 3. It's not exactly 3, but it says round to the nearest integer, so I'm going to take 3. So I'm going to write the points first here. So when y is going down again. So we have when y is, sorry, here you go. So we have when y is 4, we have 2 points on the graph, and the first point is x is -1, 4. That's the first point. And from these coordinates, I'm going to find the y, I'm sorry, the x, I need to find x. X is going to be equals to -1. And then you have another point, which is 3, we say we're going to round to 3 and 4. And in this point, x is going to be 3. So those are my two answers. And it's okay. Sometimes you can have two value for the same value for y, but x's should be all different. So when they ask you to find x could be more than 1, depends how the graph looks like. But the y coordinate always have to be only y, only 1. Okay, then you're going to look at the next example. We have D. We have we have to find x again when y is 0. So they give me y coordinate in this case. So this is y is 0. And that is what I need to find. Okay, so y is 0. It's here in the here. And then I'm gonna just do a horizontal line again and see where I'm gonna cross. I'm gonna write going down like that. So we have this horizontal line, and you're gonna see where you're gonna cross the graph. So I have 1 point here, 1 point here at 0, 0, and 1 point at 3. So because you round it to the whole number, it's gonna be the same, but I'm gonna write the point. So here we're gonna have 3 coordinates, 3 x's. So the first one is gonna be -2 and 0. That's the first point. The other one is gonna be 0, 0, 0. And then the third point is gonna be 3 and 0. And then from those points, what is the x? The x's are gonna be, we have 3 values. X is gonna be equals to -2, 0, and 3. So that's how you find the, this is pretty much reading the graph. Okay, now going to the next example. To evaluate function, so this is evaluating function looking at my on the graph. And then when I evaluate function given as an equation, we're just gonna substitute the x on the function. So this is the example where they give me, this is the example where they give me the function f of x. So f of x is just notation that tells me I have a function, and f of x represents the y. So instead of f of x, you can just look at this like y equals. So f of x is given equals to x squared minus 4x plus 7. This is given. And we need to find a, the first one you have to find what is f of -3. And f of -3 is pretty much, that's what I'm doing. I just copy and paste. So f of -3 is going to be just copy the function. And then whatever you see x, you're going to delete that x and you're going to put -3. And the same way here with the x squared, you're going to replace x with -3. And then plug it in the calculator and you're going to get your answer. Now here, always, if you plug it on the calculator, I'm going to use symbol app to show you how that's going to look like. When you plug it in on your calculator, make sure you always have parentheses. Okay, I'm going to use my calculator on symbol app so you can see what I'm doing. Okay, and I'm going to use that. So when I put this here, and I'm going to delete this, actually, this quickly goes. I just need, I need -3 squared, just exactly like that with parentheses. And then the calculator is going to give me the answer is 28. Okay, so that's all what you do. You replace x with the number and you get, in this case, 28. Okay, now, so when you plug a number, that's what you're doing. Now, the next one, we're going to evaluate f of x plus 3. So instead of, Okay, so we're going to replace it with x plus 3. So here I'm going to plug it in the parentheses. I'm going to put x plus 3 in both of those x's. Depends how many x's you have. Just going to replace it, x plus 3. And then here, because we don't have only numbers, we have also x's, we're going to simplify this expression. And how you simplify the expression, we're just going to do the parentheses first. We're going to FOIL. And then after that, we're going to distribute the parentheses and we're going to simplify. So first, we're going to do x plus 3 squared. Now, x plus 3 squared means x plus 3 times x plus 3. So I'm going to rewrite this. So we have x plus 3 multiplied by x plus 3. That's going to be square. And then I have minus, when I multiply negative 4 times x, negative 4 times 3, I'm going to get minus 4x. And then minus 12 plus 7. Okay, this is what we have so far. Now we have to FOIL here. If you remember, FOIL is multiply first and first, x times x times negative 3, negative 3 times x, negative 3 times negative 3. So when I do that, I'm going to get x squared. Okay, and then plus 3x, plus 3x again, plus 9. And then I'm going to copy everything, minus 4x, minus 12, plus 7. And from here, we know what you need to do. We just have to simplify. We have to combine like terms and get the answer. So what combining like terms means? You add in x and x squared, x squared. So here you have only one x squared. Then we're going to combine the x's. How many x's we have? Let me make it lowercase. So looking at the x's, 3x plus 3x minus 4x, that gives me 3 plus 3, 6, minus 4 is plus 2x. And then combining the numbers. So what are the numbers? Let me just kind of highlight so you can see what I'm doing. X and x and x. Combine them, that gives me 2x. And then doing the numbers, I have 9 plus 7 is what? 16. And 16 minus 2. Minus 12, sorry, minus 12. So do know the numbers. 16 minus 12 is 14, right? So it's going to be plus 14. Just use your calculator if you're not sure. It should be plus. Okay, so that's my final answer. So and remember, every time you do, you plug it in, you substitute whatever they give you in the parentheses in the place of x. If it's given number, so in this example, they give me f of negative 3. So when I replace x with negative 3, I'm going to get a number, which we get 28. So the answer for the A is 28. And then if they give me to plug it in something else, like here they give me to plug it in, what I did I plug it in? We plug it in x plus 3. Whatever is given, it's going to replace x. You have to simplify it, and the answer is going to have x, because that's what you replace x with, x plus 3. Okay, so that's how you evaluate function. Now, the next example is application on that. And here we have the cost of producing computers, software is function, and they give me the cost is given. This is the cost function here. C of x is the cost function. We talk about cost function, you know what is that? What will be the cost if the employee work 800 hours? So here in this function, x represents the hours work, and the cost function is given is